In this video we're going to be learning about amines. Now amines are a group of compounds which have got NH2 on them. So looks very similar to something we've already met before, NH3, ammonia. Now we'll notice that there's a lot of things in common, so this is worth noting. The preparation of amines is not as easy as you'd think. You'd expect that you could just take an alcohol and add ammonia and you'd have an amine. It doesn't quite work that way. What we do instead is we get the ammonia and we do dissolve it in alcohol. Because both ammonia and water are able to form hydrogen bonds, then we find that this is quite easy to do. So we can bubble ammonia into alcohol, making an alcoholic ammonia solution. So the way we write that is NH3AlC. And what we do is we add that to a haloalkane. So for argument's sake, for today, because the amine I've got is methylamine, which is the smallest one, I'm going to take chloromethane, and we're going to react those. I'm going to show you how to do the equation for this. So if I react those two together, the chlorine is substituted. So we end up getting CH3NH2 plus HCl gas being driven away. Actually, initially this will be dissolved in the alcohol. So the name of this one here is methyl or methyl amine. So the name's quite easy. There's another way that you can name it though. You can call it aminomethane. So there's two possible ways to name these. When the carbon chains get a bit longer, then you have to actually be careful how you do name them. So if I took, for example, a 3-carbon one, I could have CH3, CH2, CH2, NH2, or I could move that to the middle one, CH3, CH, NH2, and CH3. These are both examples of aminopropane, but it's just having a look at where those amino groups are. So this one would be called 1-aminopropane, while this one would be called 2-aminopropane. You will probably find it's easier to name them this way, the aminopropane and aminobutane sort of way, rather than propyl amine, that sort of thing. Because this one here isn't just called propyl amine, it's got another name, so it becomes a bit hard to name them. To be fair though, this one is called propyl amine, so you could still name it that way. Okay, so preparation. They're made from a haloalkane being reacted with ammonia dissolved in alcohol, doing a substitution reaction and leaving HCl dissolved in the alcohol. Now let's have a look at some of the properties. Well, as I said, the NH2, just like ammonia, is able to make hydrogen bonds. That means that amines will dissolve very easily in water. And I'll just show you that. So I've got methylamine or methylamine or aminomethane, if I want to call it that. And I'm going to put some of that into a test tube with some water. Now, if it does dissolve in water, which is what I said will happen, then we will see one layer. Now, sorry, I'm gagging a little bit. They smell really horrid. So that's one of the other typical properties of them. So as I add this in, we don't really observe anything, which means actually it is dissolving. Now, that very putrid amine type smell suggests that maybe I've got a base, just like amine. So while I've got the solution, I'm going to put some litmus in here and see, well, it's already happened. Without it even going in there, it's turned blue. So I'll just put those next to each other so you can contrast the two colours. Actually, this is starting to go blue just from my fingers as well. So we've got it turning litmus blue, so it is indeed a base. Just see how that hasn't been overly convincing. I'm going to put some universal indicator in there. and it's gone a blue colour there. Alright, so they are a base and very smelly. So how do I show that with an equation? Because in chemistry we like to prove things with an equation. So in this case I had aminomethane, so this here, I put it in water, and actually it's an equilibrium here because they're weak bases. It's going to gain one of those hydrogens, so it becomes CH3 NH3 plus with the hydroxide ion. So it's because the hydroxide ion has been formed, it's increased the concentration of hydroxide ions in the water, that it's a base. Okay, there's some pretty cool reactions with these, and I'm going to go through one of them very quickly with you because it's actually quite a neat one to do, to show. I've got some copper sulfate here, and because they're a base, if I was to add a little bit of a base to this, we'd expect it to make a precipitate, copper oxide, copper 2 oxide. So that's what we're going to have a look at. I'm just going to put 1 or 2 drops in here to start with. And we get that blue precipitate. You can actually see the complex that's about to happen forming at the top. If I shake it some more, okay, we've mainly got the precipitate. Now if I give a good amount to it in excess, we can see that it's gone a royal blue colour. This is a precipitate, this is a complex ion formation, just like we saw in our first unit this year. So what's happening here is that the copper, which is a 2+ ion, is reacting with 4 of our CH3 NH2s and forming quite an in-depth complex ion. It's very similar to the copper tetramine complex that we looked at earlier in the year, where instead you wouldn't have the CH3s in here, this would be NH3 and 4 of them. So it's doing the same sort of thing, but now it's got the CH3 as part of the ligand, which has created the complex ion in there. Another reaction, which I'm not going to do now, is for us to react it with an acid. So if I was to get my methylamine or aminomethane and react it with HCl, then should be able to get a bit of a guess for that if we remember our reaction of ammonia plus HCl. This would make ammonium chloride. So this is going to make something that's pretty similar to ammonium chloride. It's going to make CH3, NH3 plus and Cl minus, surely. And it does indeed do this. So how do we name this thing? Well, if this was called ammonium chloride, it won't surprise you to know that this is just called methyl ammonium chloride. So it's basically the same name. Now, I always had trouble with these as a student, so I just remembered the reaction with ammonia and then went, oh, how many carbons in it? 1, so it's methyl. 2, oh, it's ethyl. So I just remember it that way. Basically, in a nutshell, that is what we need to know about our amines. They are bases because when we put them in water, they increase the concentration of hydroxides. They can complex with copper. They can react with acids, and we need to know how to name those. We also need to remember how they're prepared. They're prepared by dissolving ammonia in alcohol and then reacting it to a haloalkane. And we need to remember that it's often easier to name them as an amino and then whatever the carbon chain length is, rather than naming them as methylamine or whatever.